Today we continue to work on our Tower Blocks game, and the goal of today's episode is to introduce a new game stage or state which happens right after the game over state but before the playing state. So we would like to add this animation which happens before we start the new game. Right now what we have is once the game is over and we either press space or click the mouse button, everything disappears right away. There is no animation, the game is restarted with score 0. And to achieve our goal, we first need to introduce new game state. Let's do that. Resetting state. Right, so once the game is over and before switching to the playing state, we will spend a bit of time in this resetting state where we will have some sort of animation where the blocks will eventually disappear. Straight away, our update game state is complaining that our switch statement doesn't handle all the possible cases. So let's add a new case for resetting state. And let's finally fix the thing which happens in game over state, where we free the place blocks, where we re-init the game and do some stuff. The problem here is like with the init game that it reloads all the things from scratch without unloading previous ones. So the shader is loaded for every game iteration without unloading previous ones, unnecessarily loading the same cube model again and again without releasing it, resetting some states. We don't free the falling blocks, they disappear once the game is restarted. And we would like to handle that by using different helper methods, something like ResetGame, which does only the things that are actually needed to restart the game. So in this case, if we are in game over state, we are not freeing anything, we are not initting the game, we are switching to a new state, which is resetting state. We don't create the current block, we no longer need to reset these things, as they will be remaining from previous playing state and else statement. We need to keep the fading out, and then nothing really. I don't think there's anything else for us to do. Pretty much we're saying that once the input is pressed, we are switching to the new state, we are fading out the game over, right? And we're spending some time in this thing. Now, if we run it, we end the game, we press spacebar, you saw that game over overlay faded out, but really nothing is happening here. There's even not a new moving block here. And this is all because we dropped the game reset thingy, right, which we used init game for. And now we need to somehow indicate that, hey, we need to do some reset game over here. So in init game, we did a lot of things. And right after that, we can define reset game for our, oh my god, what's that? Reset game. So what do we really need? We don't need to reload the shaders, the model. We can probably say that we can now go back to playing state. We don't do anything to falling blocks, placed blocks. We can redefine these two things just in case. Color offset we redefine so that the new tower can be built with different colors than before. Animations, we don't reset anything. And yeah, we need to reference the correct previous block. One thing here is that in init game we pretty much just dropped falling blocks incorrectly. We didn't free the array, we just set it to null and that's it, and created new falling blocks. But what we really want to do is we want to clean them up a bit, but do not make the falling blocks disappear. So if the reset game is happening and there are still some blocks flowing down or falling down, we don't want them to disappear directly as they are currently doing. So what we need to do is we need to iterate over all the falling blocks that we have. Let's say array length of falling blocks. And then we can iterate for starting from the end, because we would like to remove some of the falling blocks. Pretty much if we check that if, or let's say falling block, let's get a pointer by the index I, if block is not active, we can actually remove it, right? So we can use the array_del swap. This one is tells us that it deletes an element, replacing it with the one at the end, so that we get O1 performance. We don't need to like move the rest of array over, which is done using array_del or array_del_n. That's why we use array_del swap. We can say that hey, falling blocks at I we can remove. So a few blocks from previous game which are still falling, they remain, they will be still animated, and once the new game starts again, we will clean them up so that we don't ever pile up too many falling blocks, but at the same time we keep the ones falling up until they become inactive. So this reset game looks just about right, should be enough. So one thing, let's see like how it works out. So once the game is over, let's press space, and our block is new block, moving block is working just fine. But this previous state, all the placed blocks that we haven't cleared, they remain, and we need to somehow handle them. So what we want to do is upon user's interaction, so whether spacebar is pressed or mouse is clicked, we want to tell our game that hey, let's start tower collapse. So this will mark somehow our placed blocks that it is time for them to disappear. And they're going to do that, they're going to be disappearing during this whole resetting state, and only when the initial block at index 0, our first block which never moves, remains, then we can actually do the reset and create new moving block. So what I mean by that is that in case we are in resetting state, we check whether our placed blocks array is of size 1, and only then we can do the reset game, we can do the current block, the creation new current block. Now what is this StartTowerCollapse? Let's think about it. Alright, so first of all we need to see how many blocks we have placed. Then we can iterate over them starting from index 1. So the first block at index 0 we don't touch, it's always there. I less than length. We can grab it. Game place blocks by index I. Oops. And then somehow tell the block that it is time to disappear. Let's mark it as maybe unused for now so that there is no completion error. So here is the thing that we need to somehow tell the block, hey, you are being removed. Right now, with our block struct, there is nothing here, and we need to define a new property. Let's call it removal. And this property is going to be responsible for the whole removal animation. Let's define a new struct, call it removal. So the removal can be active or not. Maybe we can even, let's see like whether we can do without the active and simply rely on game state for now. What we need to know, we need to know some timer. We will need to know some delay for each block. So we want to the tower to collapse starting from the top block, so from the last placed ones, and go towards the initially placed blocks. So go towards the beginning of the tower, and this delay for each block will make it so that animation for each block starts later the closer it is to our initial placed blocks. Alright, so what we also need is probably just scale and rotation. So these two things are going to be responsible for our animation. So each block, once we started animating it, it's going to be becoming smaller and smaller based on scale, and it will also rotate. So that's the plan. Let's see, first we need to define some defaults. Removal. Oh my god, what is that? Removal. So delay 0, timer 0, scale 1, and rotation 0. I think there is also create moving block, which also defines the block new one. We can paste the same section here. When we run, really nothing happens, right? We're still stuck. Can't do anything once the game is over. So let's get back to our StartTowerCollapse. Now we can actually say that, hey, like block removal delay is something more than 0. So we need something like length minus y times some sort of delay. So the last block on top of the tower, its index is actually like really close to length, which is like length minus 1. It will have a delay of 0.05. The next block, which is second from the end, will be 2 times 0.05 and so on. So this StartTowerCollapse sets the delays, and really it technically I wanted to set something like active true, but I believe we can simply rely on the game state in this situation, and maybe it's a good idea to have it to explicitly set the removal, but let's see how we can deal without it. So even though the removal is set, the delay is there, the default scale is 1, the rotation is 0, we aren't doing anything yet. And to do something with our placed blocks during the resetting game state, we need to introduce yet another update function. Let's call it UpdatePlacedBlocks, game and delta time. Let's define it here. UpdatePlacedBlocks, game and delta time. So first of all, we can simply check if game state is not resetting. There's really nothing for us to do here. We can return. So this method is all about that resetting state stage, where we want to start animating things. Next, we need to iterate over all our placed blocks yet again. So we grab the length of placed blocks. We iterate it in reverse so that we can remove blocks again. Size ty equals length minus 1, I is greater than 0. We can grab the block by index y, and then what can we do? We can say that removal timer plus equals this delta time. And now as each block needs to start its animation based on its delay, we can check whether the removal timer has actually exceeded the delay that we set for each block, the delay. So if our block at some random index 5 has a delay of, let's say, half a second, the timer first needs to reach this half a second by accumulating all those delta times. And once it reaches that hypothetical half a second timer mark, it can start adjusting the scale and the rotation of our placed block. So first of all, let's define some float t, which is going to be block removal timer minus block removal delay. So that's actually how much time has passed after like the delay value has reached and our timer went over. So this is amount of time we spent animating this block. So it starts at 0 and when timer is equal to delay, and the timer keeps growing, so this t also keeps growing. We also want to limit this t probably to something like 0 to 1. And we can limit it by dividing it by some duration that we want this animation to happen. Let's say 1/5 of a second. Next, we can define scale, which is going to be 1 minus t. Why is it 1 minus t? You can think of it this way, that once the timer has reached the delay, this value is going to be very, very small. So t is going to start at value of 0, and slowly but surely it's going to be growing towards the value of 1. So because t starts at 0 and starts growing slowly, the scale needs to be initially 1, right? And it needs to become smaller and smaller towards the 0. So that is why we have 1 minus t. So when t is 0, scale is 1. When t is 1, scale is actually 0. And what we want to do is that probably if t is greater than like something like that, this can be configurable. I'm saying that once we have almost reached the full 1/5 of the second, we can actually at that point of time the block will be like very, very small. We can stop any kind of animations and simply drop the block. We are going to use the same array delay swap game place blocks at index y. Now we need to use that scale to set our block removal scale, is this thing, and we need to also set removal rotation, which can be something like t, but we would like to be to rotate it a bit more. So again, like this constant, you can play around, you will see like how it affects our rotation. If we run it, now I'm pressing the space, and you saw that the blocks disappeared. Let's collect a bit more of these blocks, let's say like 10, 9, 10, then end game. I'm pressing space. Internally, we are updating this removal struct, but we are not using it to animate the blocks. We aren't using that data when we are rendering the blocks. So I'm pressing the space right now, and you can see that they are being deleted one by one. Let's jump into our DrawBlock method. We have our block, lighting shader. We don't use the removal thingy, and we should do that. We can probably achieve it by using game, which already has lighting shader. So we can say game lighting shader. We can also probably drop this begin shader mode and reuse what we had in this falling block method. I'm simply copy pasting it. If you have time, we can actually extract it and reuse the method. But what we have here is this. We're once again normalizing the color, setting the color for the shader, then we're scaling our X, Y, and Z. We can multiply the X by removal scale. We can skip multiplying Y. I'll explain why in a minute. And again, we can multiply Z by our block removal scale. Removal. Right, so when we're removing things, we keep the Y so that the height of the block remains the same. The rotation, it actually expects us vector, and we would really like to rotate rotate around y-axis and no x or z rotation, which means that we can define vector 3 where x is 0, y is something we don't know, and z is 0. And what is y? Really, it's simply block removal rotation. Then we translate to its position, multiply all the matrices, set its transform. And now we need to simply fix the DrawBlock call, as we're now using different parameters. There are 2 places where we invoke the DrawBlock. Let's see what it does to us. Let's collect like 5 or so blocks. And game over. Let's press that space, and that is exactly what we wanted. Let's try to collect a bit more, something like 20. You can also try and keep track of those falling blocks. You can see that they're not removed and still falling. The new game has started, but those falling blocks are still there. All right, so one thing, let's get back to this UpdatePlacedBlocks. So this affects how fast the scaling happens. 1, 2, 3, game over. Yeah, they were much slower now. And this affects how much the rotation is. So if we do it by 2, and we do the game over, you can see that the rotation was really, really slow. So these are kind of constants that you can play around and see which of them, what values make this animation look somewhat good enough for you. So in my case, I believe that those values that we are currently having is enough. The really nice thing is that when the blocks are removed, we have the counter which goes down to 0, so it doesn't reset to 0 right away. So because we're removing the block once the t value is like at 0.9, and then our camera is also not jumping to the initial block, but it's actually based on the height of the tower, so it's also smoothly moving towards the initial block. So this is what I mean. The score was counting down, the camera was smoothly moving, and again, our falling blocks are not disappearing, but we do the correct cleanup. This is pretty much it for this episode. All I wanted to show you is kind of a animation that we can do in between steps, how we can do it. And one last episode, most likely, hopefully, will be dedicated to sounds. We can have some background sound, we can have those placement sounds. The perfect placement should have a different sound so that you know that, hey, that was a perfect placement. Maybe some game over sound. Yeah, so that is the goal for the next last episode. But even now, the gameplay is already finished. It's really nice, good looking. Lots of things we learned throughout the series. I really hope you liked it. And if you did, please don't forget to like the video, subscribe to the channel if you haven't, because it helps me greatly. And I'll see you again. Bye.